Love this. You see this right here? Newspapers are not returnable. I can see why people want to return them when you get sensational headlines like this. Take a look at this. You got Hurricane Matthew menaces entire southeastern coast. Let's look at another one. Killer storm targets Florida. Okay, let's compare those two to this one right here. Hurricane aims at Florida coast as millions flee. You drop the sensationalism, just give you the facts. Not that sort of clickbait that gets you to click onto an article online. Speaking of clickbait, let's read some of that right there. How about this one? Killer asteroid, Bennu, on collision course with Earth. That's going to get me to click, no question about it. I even like this much better on the news. This is ABC News. They just said asteroid study, not killer asteroid or Armageddon asteroid, because the movie Armageddon was about an asteroid that was going to take out space. So this is actually really interesting. NASA, by the way, is going to visit this asteroid that's coming somewhat near Earth. And maybe near is not the right word. It's so far away. How far away is it? Well, it turns out there's a 0.0006% chance of it hitting Earth in 2021 right there. So like a century away. So NASA's actually going to it, but they're not going to try to push it away. They're actually just going for samples. But NASA is doing a redirect mission with a different asteroid. They're actually pretty much going to a different asteroid and seeing if they can like nudge it and if it'll move away from space just to better understand. Let's say there is a killer asteroid on the way. Can NASA send something and nudge it and move it away from Earth? So kind of interesting there. But it's just those sensational headlines. People thought, why is NASA going to some comet that's coming, air quotes, near Earth, but not trying to get rid of it? No, they're just going to visit it to get some samples because comets are leftovers from when the Earth formed, as are asteroids and all that sort of stuff. So NASA wants to get some of that asteroid samples to better understand how did everything in space form. So take a look at this. These are some actual images of what an asteroid looks like. It's kind of rocky. Kind of almost like you're in a desert somewhere. So the movie Armageddon kind of takes a closer look at these asteroids. Let's get you some baseline on what an asteroid is. In short, it's just a giant rock in space. That's the best way to explain it. This particular asteroid that had those sensational headlines, it's the size of about 4.5 football fields. In the movie Armageddon, the asteroid way, way bigger that was coming toward Earth. And one of the biggest flaws of the movie is those astronauts go to it and they walk around the asteroid like they're here on Earth. That's not the way it works. You've got to be something really big in space to have gravity to anchor you to that spot. In the movie Armageddon, when they went to that asteroid, which by comparison, something in space, it's just a giant rock, it's not that big, well, they should have just floated away. They shouldn't have stayed on there. So that's the one big error in that movie right there. So in order to have gravity, it depends on how wide something is and also how big something is. So in late 2021, NASA sent their investigation mission to get a little sample of the Bennu asteroid just to better understand it. And eventually it's coming back to Earth in about a year or two from when I'm recording this video with some of those samples. Okay, let's compare an asteroid now to a comet. Comet traditionally is a smaller rock, but there's more to it. So asteroids are pretty much just rocks. Comets have some more. They usually have dust to them. And dust means just like little pieces, tiny little pieces of rock. Like think of it in sand. Sand, by the end of the day, is just little pieces of rock. So they got dust, and they'll have some ice to it. What'll happen is when some of that ice and that dust moves into a part of space where it's kind of right by the sun, or the sun's beating on it, all that frozen little pieces of ice, well, they become water, and then they become gas, and that helps like a cloud form. So a lot of times, kind of around this small rock that's the comet, you'll have like some dust to it. You'll have almost like a cloud, a tail is what it gets called a lot. And that's just because when that ice becomes liquid and then gas so quickly, it leads to basically a cloud forming from the rock dust. And that moisture eventually refreezes. So that's kind of what a comet is. And what's interesting is they're messy. Think of it as like a messy snowball on top of the rock that's like at the center. And that dust is left around in space. And as the Earth moves around the sun, every year at the same time, it'll run into these paths of comet dust that are left in space. And every time the Earth runs into one, that leads to a meteor shower. It's these little pieces of dust, literally, think of the size of sand, that leads to the meteor showers, the shooting stars that we see. A shooting star is a meteor. So that's how we get them. Now, occasionally, we can get a meteor shower from some dust of an asteroid, but that's kind of rare. There's a December one that's the case. But usually any meteor shower, it's coming from the dust of a comet when the Earth runs into it. Some of that dust sneaks into the Earth's atmosphere, and it actually does not burn up. You know what it does instead? What that dust does is it agitates the air way up in our sky. And when it agitates the air, what it ends up doing is it kind of energizes that air. And the air way up, we're talking like 50 to 80 miles up in our sky, it just can't handle that extra energy. So it gets rid of it. You know how it gets rid of that extra energy? It gives it off as light. And that glow of light you see from a shooting star, from a meteor, it's that agitated air getting rid of that extra energy, and you're seeing the light streak in the sky. So, no comment. Dust is burning up. Though what does happen is that dust falls to Earth just from the friction, like the kind of like the pressure on all that dust as it moves. It kind of warms up, and it just breaks apart smaller and smaller and smaller. And if it's a size like a piece of sand to begin with, it's not going to be long before it breaks up. So that kind of goes back here. And what's interesting is in the movie Armageddon, they kind of got something right there. They talked about a meteor shower taking out the space shuttle, like the International Space Station. Well, you know, not necessarily the dust will, but if the rocks were bigger, that certainly could be an issue to it. But at the end of the day, meteoroids, you know, a lot of times they're just little pieces of dust and not quite big enough to take something out. They certainly can. There's plenty of little tiny pieces of rocks from comets and asteroids out in space that certainly could pose a real problem to something up in space like the International Space Station. But most times, we're just talking dust here. So let's move around and kind of talk about the difference between a meteoroid, a meteor, and a meteorite. Okay, they're all the same thing. It just depends where it is. So, asteroid, big rock. Comet, smaller rock with some dust to it. Pieces of that rock, some of that dust. Well, when it's up in space, we would call it a meteoroid. Kind of like these little small little pieces of it. It's smaller than a comet, smaller than an asteroid. That rock dust in space, we'll call it a meteoroid. When it comes into the Earth's air, we'll call it a meteor. If any of those little pieces of dust, or maybe even rock, if it's big enough, hits the ground, it gets called a meteorite. So, all the same thing, it just depends where it is, and that's what dictates the name. So, we'll kind of look ahead here to ways that we can monitor for like these big asteroids in space that potentially could take out the Earth. There are several ways to do it. You can actually use radars to do it, and you can actually use something where you actually just kind of listen, think of that in air quotes, listen for the energy coming from space. And by kind of actually pulling in some of that energy that's coming from space right now that we can't see, but devices can capture that type of energy, we can actually kind of paint a picture of what is in space. And there's different ways to do this. So at NASA, for example, one way is they'll have kind of a group of radars. They send that energy into space, that energy hits something, and how much energy returns back to the Earth tells you how big that object is. You can get a feel for how big it is. Now, other ways, and this was kind of cool, this was down in Puerto Rico. There was a giant space observatory. They kind of had radar, but they also listened for energy that was coming from space. Unfortunately, it fell apart. A cable snapped, and down that whole thing went, so it's long gone now. But this was our first kind of defense in detecting a giant asteroid. Even detected this right there, a skull-shaped asteroid on Halloween nights, actually, I think, when they detected that. Kind of creepy, right? So this kind of talks about not only the way that kind of radar works, but also there's radar telescopes that are just kind of pulling in some of that energy we don't see, a different type of energy that's coming from space, to figure out how something works. And the movie Contact is a pretty realistic movie in describing how that process works. It was filmed in this part of New Mexico, and where they filmed it's still there, and what happens is all those little big old satellite dishes, it's a strength in numbers. They kind of all join their energy together to kind of get a bigger picture of what's going on. There's about 27 of them. And they have to be really big because there's not a whole lot of energy that's coming from space, but that's what they're interpreting. and analyzing. So they need to pick up some of those little nuances that are coming in. Another way we can listen to kind of space is getting how not only energy travels, we were just kind of talking about sound energy, there's also light energy to detect things. This particular telescope right here is using the light of stars, not just the sun, other stars, to figure out what the air is like on different planets. So this is the James Webb Telescope. It launched in 2021, right on Christmas Day. And the way it works is when a planet outside of our solar system, that just means it's called an exoplanet. There's more than 9 planets, 8 technically, if you would say in our solar system. Pluto isn't counted these days. But when there's a planet outside of our solar system, I think we kind of want to know more about it, right? Did you know there's actually 4,000 plus planets discovered just since the 1990s? That just shows you how quickly our technology has changed. We didn't really have the power before the 1990s to detect planets outside of the ones orbiting our sun. That's our solar system. Well, the technology changed so much in 30 years that now we've discovered 4,000 plus planets. I say plus because we're going to just discover thousands more, particularly with that new James Webb Telescope, the most powerful and biggest telescope ever launched into space. And telescope just means it's detecting information in space and analyzing it. So this is interesting. So with some of those 4,000 planets, we can figure out what the air is. And here's the way it works. When one of that planets moves in front of its sun, that sunlight, in other words, the light coming from the star that moves in front of, well, air is actually going to do different things to that light. Depending upon what the air is made of, the different gases, that light will move differently as it moves into one of these gases. And scientists understand how light moves in each one of the gases. So they're essentially going to get a snapshot of how the light moves, and based on the way it moves or bends and things like that, when that sunlight moves through one of these planets, it's able to figure out what air, if any air, is on these planets. And from that, we'll find a planet that'll be one that we could breathe on, because just think about if there's 4,000 plus planets, there's got to be one that's got enough nitrogen and oxygen, or at least oxygen, that we can breathe on. So that's one of the big things that James Webb Telescope will be doing. It's kind of like the movie Interstellar, where they wanted to find a new Earth. They weren't necessarily using the telescope to figure out the air on it. They already figured out the ones to go visit. We'll assume they already got the information from the telescope. It sent humans to actually go check out the planets on ones that they thought we could live on. We would probably send robots and not humans to go visit some of these planets. We have a robot right now on Mars, checking out Mars, better understanding about what the ground is like on Mars and how things work on Mars, and investigating what's there. It's about the size of an SUV. When I come back, we'll chat about the different air on these different planets that are in our solar system going around our star, the sun.